Tēnā koutou, tēnā koutou, tēnā tātou katoa. My name is Amy Strang and I'm an engineering graduate at Air New Zealand and on the FLINT leadership team here in Auckland. Hosting alongside me today is Chris Womby, who is co-lead of Air New Zealand's Young Professionals Network, and Craig Young, who is CEO of Tuans. We'd like to welcome you all to our event today, using innovative technology to thrive in a post-COVID world. We all know that the last couple of years have been challenging, with an ongoing COVID-19 pandemic that continues to throw us curveballs. Many of us are missing family and friends from overseas and have struggled with the uncertainty of border closures and what the world might look like as we begin to open up again. But as our tools for living with COVID mature, we can begin to look to the future and get excited for the opportunities that new technologies will bring. Today, we'll hear from three knowledgeable speakers on innovative technologies that will support how we travel and move around the globe. We'll touch on the maturing of 5G and communications technologies, sustainable aircraft, and the use of digital technology and data. Our speakers will each have 10 minutes to present, followed by 5 minutes for questions. You can ask your questions through the Q&A button down the bottom of the screen. Our first speaker up today is Helen Littlewood, who is the Digital Innovation and Strategy Leader here at Air New Zealand. Helen is presenting on the democratisation of data, where she'll bring us up to date on the implementation of the Iata travel pass, which will enable us to move around the world in these mid-pandemic times. Welcome, Helen.
Tēnā koutou katoa. Thank you so much, Tuans and FLINT, for inviting us to come and present. I'm really looking forward to sharing more about Iata Travel Pass, but actually I'd like to share it in the context of a wider and complex system that is technology and innovation. So I'm just going to share my screen here. Can everyone hear me okay? No problems? Great, here we go. Okay, IATA Travel Pass and the democratisation of data. In the last 2 years, time's taken on quite a different dimension through COVID, and Air New Zealand's been working with urgency for a better future state since the health crisis unfolded. So today, given the audience, I'm actually going to make this quite a, bring you some technical insight rather than necessarily how to use IATA Travel Pass, and talk to you about how innovation, how complex this innovation is, and landing it within a complex environment. I'm also going to finish off with the 2-year vision and where this technology is taking us, and actually how you might apply it in your own organisation. So I'm going to start actually in August 2021, and probably most of you are aware of the narrative in the media. It kind of went something along the lines of, how hard can it be if you turn up to the airport with your vaccine certificate or your vaccine letter saying that you've been vaccinated and you've got a pre-departure test, how hard can it be to make that work within the airline system, within the border system? The answer is quite hard. And so I'll take you back to 2020 when I last spoke, was presented to Tuans and FLINT, and talk to you about the various different technologies that we looked at to unlock travel. And through 2020, the common narrative between everyone was, we can help you unlock travel. That was, we were being approached probably 3 or 4 times a week by the various companies who had the answer to unlock travel. And you probably remember the technologies that were being discussed in the media, and they often got quite good airtime because it was thought that was the one thing. But ultimately, it's a combination of multiple technologies that's helping with the restart of travel. So thermal scanning was quite popular. In 2020, we looked at cleaning robots. I remember measuring the size of cleaning robots to see if we could get them down the aisles of planes to disinfect planes between flights. We had people approaching us suggesting that, with AI and data analytics, we could do cough analysis, so we could actually identify people who were traveling and pull them out. But you can imagine being at the airport and having that scenario and being there with your family and your and your 8-year-old has COVID, and suddenly you're yanked out and unable to travel. So that doesn't make for a great travel experience. We were looking at vitals monitoring for our crew to keep them safe. But the concern with vitals monitoring is actually all of the personal health data, which has a really high bar of guardianship. Masking technology, simple but effective, and that one has persisted all the way through. COVID mapping, we were looking at things like weather reports, and there was very complex data and analytics going on. We were being approached by companies who were able to give us quite precise risk profiling from destinations. But the precision of those estimates of the risk of somebody having COVID from a particular destination meant that each route needed to be highly individualized, which you can imagine with a really complex aviation system is hard to manage and maintain. I've been spoken with companies such as Boeing about airplane airflow and actually the movement of air, and we now know, and there's been a lot of studies done, that actually on the plane, because of the refresh of the air and the way the air flows, there's actually very minimal transmission on planes. We've looked at environmental risk assessment, what we call dwell times in airports. So there's been data analytics done on that, and the cumulative risk profiling of people coming through an airport scenario. So being on the plane is one thing, but we all know we need to get into to ground transport and get to the airport. Testing technology, and that's coming on in leaps and bounds. And I think 2022 is going to be the year of testing technology, and that's actually going to be a bit of a game changer. And we finished off 2020 with health passports. Actually, 2020 was full of digital health passports starting to shape up, what they looked like, where they stored their data, how it all worked on a global scale. Was ambitious, and it was the direction that's taken us to now. So New Zealand approved an Iata travel pass trial on Christmas Eve. That was quite memorable for me. I'd actually finished for the year and got brought back into work to present on the work I've been doing. And we started off 2021 knowing that we were going to be kicking off a trial of Iata travel pass. So Iata travel pass doesn't exist in a vacuum. It's not something that the airlines can just adopt and not, and have it work all by itself. Here I'm presenting more circles because it's just these systems, and these are all really large, complex systems, all need to work together in order for Iata travel pass to be effective for our customers. So we have the Ministry of Health, and we've got the requirements, and not just our Ministry of Health, we've got all of our destinations ministries of health, all making rules, changing rules. There were multiple changes a week sometimes while people were mid-flight, and those are the ones that often made the headlines. We've got the airlines, but obviously not just Air New Zealand. Air New Zealand works alongside multiple code-share partners, and anything that we do needs to actually have some sort of standardization amongst the various airlines so that we can share customers on code share. We have customs, and customs technology is coming along in leaps and bounds as well. You may have heard about the New Zealand Travel Declaration that's going to be released towards the end of March. MIQ and the complexity of actually the intersection of lining up travel with the right documentation, with the right entry, into MIQ. We've got airport systems and the physical changes that they had to make to the airports in order to be able to have even 2 levels of risk coming through. We had what we call the green lane during the bubble and the red lane, and had to be kept completely separate and have 2 entirely separate systems. We've got government regulations all over the world, and governments, and I think everyone would probably agree that COVID is not just a virus, but it's the application of the various politics of the governments around the world. Then no small feat, we've got lab networks. Where do you go to get a pre-departure test? Have I got the right one? Is it in the city? What do you do when you're in a strange city in order to get a pre-departure test? And then COVID research, testing technology, which, as I said, is something that's coming on leaps and bounds. And then we've got the complexity of people and how people act and react under stress. And let's face it, traveling has been quite stressful for the last 2 years, but it is going to start stabilizing in the coming 6 months. We'll see a little bit more predictability, and certainly that's what Air New Zealand is working towards. So the trial started in April 2021, and here's a bit of a look at the structure of Iata Travel Pass. You can actually download Iata Travel Pass. We've gone live. Air New Zealand's gone live with Iata Travel Pass, which means that we have shared our flight information with the technology, so that when you download and set up your profile, you're able to choose a flight if you've booked a flight, and it will take you through the various pieces of information. It will tell you the entry rules, and you will need to do some various things like a pre-departure test. But in the background, it works. There are some core components which is really interesting to make up this global and world complex technology. The first one is digital identity, and you'll notice that as soon as you set it up, you require your passport. Actually, I still have my passport on me. I've carried my passport around more for the last 2 years. It was totally unexpected than I have ever done so before. But there's also an engine called Tematic, and this is an engine that is run by Iata, and that is used by travel agents all over the world and airlines to support our customers into what the entry requirements are. Now, once upon a time, they were really stable, but we've leaned more and more on Tematic in the last couple of years as the entry requirements have changed rapidly. And there you can see the lab registry and the lab verification. And so they all tie together, and it guides you in how to get the various requirements that you need for your particular journey. And the last, and sorry, 2 key components of that, and I want to emphasize that my COVID record and the vaccine checks are incredibly important, and that's the Ministry of Health work, and the New Zealand Traveller Declaration is going to become increasingly important. But the DIDs, I'll touch on it briefly, but the DIDs and W3C is something that I'd really encourage you to go and research and understand. DIDs are decentralized identities, and W3C is the World Wide Web Consortium. I will just touch on this briefly because I think I'm reaching time pretty quickly, but future borders, because the innovation didn't stop at the technology, we actually needed to come to an agreement. So I worked on, I led this future borders piece of work with the government, and you can see the sponsors there. And we had about 50 professionals from across government and industry working together to create a framework to allow flexibility at the border, but actually allow a functioning border with the input of industry into how that works. And you can see that starting to come to life with the border announcement. So this is work that was done in August, October last year. So I'll just leave it here. This is the challenge to you, is that I have been working in this space for a good couple of years now, but the decentralized architecture is going to be something that is going to impact all industries in New Zealand. And this is actually a terrific post-COVID data architecture, data infrastructure moment that as future leaders, I would be charging you with investigating. So decentralized identifiers, or digital identities that belong to individuals and allow them to move through a data world, is going to change our relationship with data and release us from big tech in the way that we are currently beholden. So Digital Identity New Zealand's leading the charge, and actually the New Zealand government has before a select committee Digital Identity Services and Trust Framework bill that's going to come into action in early 2024, is my understanding. So I'll pause here for questions.
Awesome. Thank you so much for going through that, Helen. I'm actually really looking forward to see how seamless this all is, because I'm planning to go to Australia in April, so that should be good. So I've got a question here. I was wondering what was the most challenging and rewarding part of working on this project and kind of how the ever-changing nature of COVID affected all of this?
I think that the most challenging part of it was that it touches almost every system of the airline, and it actually goes from the micro, which is the individual traveller moving through complex systems, all the way through to the macro. So along the journey, and I didn't even touch on it, was this APAC working group. I set up a working group of 7 or 8 airlines in the Asia Pacific region to encourage standardization of adoption of technology, because the airline systems, it's a bit like looking at spaghetti junction. It was built for purpose and it was fit for purpose, but now it's complex and tangled. And actually that's why it's hard to innovate within aviation. So that's probably, and then once you look at, so you're bringing together the intersections of really complex systems of health, aviation and government. It's been a lot of talking.
Imagine. Awesome. So we've got another question here. Did you end up using any of the thermal scanning devices or the cleaning robots that you touched on earlier?
So the cleaning robots we haven't used, but we are seeing them in various airports. So that the scanning devices is actually probably more of an airport technology, and potentially used by health services around the world in the airport environment rather than by the airport companies themselves.
Okay, awesome. So at the moment, that's about all the questions we've got. I'll give it another 10 seconds and see if anyone else pops a question through. But thank you so much for presenting all of that, Helen. That was really great.
Absolutely.
Okay, we've got another question here. Have you found all of the various stakeholders have been willing to commit to a unified standard?
The complexity is that the airlines may come to agreement, but actually it is there's a knock-on effect all the way through. So even if you get the airlines to agreement, then you've got all the health services, and then you've got all of the governments. So ultimately, the beauty about the adopting decentralized and open source technology, which is the W3C, is that actually it allows for each entity and organisation to work at their own pace, but adopt common infrastructure. So in other words, no single entity needs to own the connective tissue that is the digital architecture, but are able to build their functionality and know that it works together. So I think that ultimately at the very heart of the agreement, what we need is the data standards within W3C and the web standards within W3C to be common and commonly adopted and commonly understood. So if we can bring it down, that's the centre of the blast radius, not the governments, not the airlines, not the health services. They can just be adopters of that technology.
Awesome. And we've got time for one final last question. So Australia already has robust digital identity and processes and systems in place. Is this something which is potentially looking to be mirrored here in New Zealand?
So Australia's digital identity is what we call a centralised identity. It's been stood up by the government, and it's essentially a digital identity, much like Singapore, which allows citizens to be able to engage with government. So they were able to leverage that for what they call, for their vaccine passes quite early on. And they invested a huge amount of money in that through 2019 and 2020. In New Zealand, we're looking, I think they still haven't settled on it, but they're looking actually what I think is a smarter solution, and that providing the framework for people to be able to adopt a decentralized identity. So that will be one option. There may be various options, and RealMe still exists, and that is what I would call a centralized identity that's been around for a decade. But by adopting by laying the groundwork for decentralized identity, it actually gives citizens more control over their own identity. And I think that is a smart, and it definitely feels like a future-focused way to go.
Awesome. No, thank you so much for your insight on that. So that's about all we have time for today. So I'd like to thank you so much for sharing, Helen. That was awesome. And next, we'll move on to our next speaker, Renee Mataparae from Spark. She leads the Technology and Evolution Tribe at Spark New Zealand. Today, Renee will share on the implementation of mobile technology that will help you move around the nation and the globe. Over to you, Renee. Thank you.
Thanks, Chris. Kia ora, everyone. I'll just bring up a few slides to talk through technology and how that's going to help us in the future. All right. So our goal at Spark is really about how we help all of New Zealand win big in a digital world. But I guess, what does that mean? And then what might technology mean for all of us land-bound Kiwis that have been stuck in New Zealand and desperate to take flight? So at Spark, we're focused around the rollout of our 5G network, and you can think of 5G, it's not just a G, it's really the next evolution of wireless technology for New Zealand. It's the next evolution of everything that you have connected outside of the home. And at Spark, we started on our 5G journey 4 years ago. We started initial testing in Wellington, and we launched a lab down at the Wynyard Quarter in Auckland. We're now live across almost 20 locations across New Zealand, from Auckland down to Invercargill, and we're investing a significant amount of money in this space to help to accelerate the adoption of the new technology. And the idea behind that is not just to roll out technology for technology's sake, it's about bringing to life the use cases and the way that people's lives can be impacted through technology, and helping New Zealanders to understand what that is. So we've taken a slightly different approach to how we roll out 5G. Each time we've rolled out in different locations, we've showcased different use cases of the technology in different regions. And so what I was keen to do is talk you through some of the examples where we've actually launched with these use cases, how we've used the technology, but then more look at what could it be used for in the future, particularly around how it can help make travel better for airlines, but also for us as passengers. So if we take a step back, 5G being the fifth evolution of wireless technology, first off, we had 1G, and I don't know how many people on the call would be aware, but people used to wander around with suitcase phones. This was all of a sudden you could take a phone call outside without being tethered to a fixed line. So it was all about voice. In a 2G world, the most amazing thing was that all of a sudden we could send a text message that was, I think, 120 characters. And as a uni student, I could all of a sudden send a message to my friend down in the dorm to ask if she was ready to go for breakfast. And that was super exciting. Also saw the invention of the game Snake, which has made a comeback in recent times. Jump forward to 3G. And this was the first time that we started looking at data. So giving a really limited ability to be able to browse. But you guys will all know when you're on a 3G connection, which happens sometimes today still, it's pretty slow. It doesn't quite let you do all of the things that you want to do. 3G was really the age of the BlackBerry. The BlackBerry was about emails. It was about syncing your calendar. Before you had these, you had to bring your phone and plug it into your computer for it to update your calendar appointments. So it was a big jump in efficiency for businesses. Then we got 4G, and that was where it started to get really exciting. So 4G to start with was all about video on the move. So it saw the birth of things like YouTube, Netflix, but then more than this, it accelerated a shift in business models. So it really fueled the internet age. Mobile browsing became a big thing. So it shifted from being PC or laptop-based browsing to mobile phones being the biggest channel. And it also saw things like on-demand services. So where you needed to order food in real time. So the birth of things like Uber Eats, a real shift in traditional industries. And so you can think about 5G as being the move towards an unlimited area. So if you think about the rate of change from 1G, 2G, all the way through to 4G, with Uber, Netflix, Spotify, Pokemon Go, all those sorts of things, 5G is really the platform that will create that next step change in business models and evolution that will have an impact across both consumers and business in a big way. So, what is 5G? 5G is made up of what we talk about as 5 different features. And these features come together in different ways to enable different use cases. So we've got speed and capacity. That's the first benefit that you get from 5G. So it means you can download things really, really quickly, so super fast downloads. It also means that we've got a big focus around delivering wireless broadband, so broadband services to your home over the wireless network. And when you do it that way, it's pretty easy to move around, much less tied to that fixed line or fibre line. But the real game changers for 5G really come when you get these newer types of features and capabilities. So around latency and reliability, you can think of latency being your responsiveness, or how quickly you get a response back, the return time trip for a packet of information. And that really helps when you're needing very quick, real-time, time-sensitive communications, which comes to the reliability as well. Massive IoT is a really interesting one. We do quite a lot of work in the Internet of Things space at the moment. What 5G unlocks is a huge increase in the density of devices that you can connect. So rather than it just being the limited devices that we connect today, it becomes connected everything. Fridges, lights we have today, but it'll be everything out and about, smart cities and all that sort of thing. The next two talked about probably a bit less when we talk about 5G, but they're the ones that are really exciting. So network slicing is a new capability that comes in with 5G. And what it allows you to do is create these slices of the network, and you can tune those slices to work specifically for the use case that you're trying to support. So today we have to tune the network so it works for text, it works for voice, it works pretty well for video. We optimize for that. It's pretty good for gaming, not the best. In the future, what we would be able to do is create individual slices of the network for each of those things. So there can be a gaming slice that's created that has the best latency. That means that you can be competitive in the global esports games. It means that we can create specific slices for things like public safety and those sorts of networks that require a higher degree of reliability than others. And so it also means that you can end up with slices that might be lower cost for people that don't need the reliability. And then edge computing, I'll talk about that a bit more when we get through to some of the specific use cases. So what have we been doing in the 5G space, and what are some of the examples? And I've picked a few that are particularly relevant in the travel space. So mixed reality, which is kind of a combo between, you've probably heard of augmented reality, which is where you've got, it's your Pokemon Go type experience. And then virtual reality, which is that fully immersive experience. So we've been playing around in this space, and I'll just play a quick video, which hopefully will get the sound. Hang on. So what that video shows is an augmented art trail that we launched when we went to Dunedin. And so what it did was, there was a really big street art culture down in Dunedin. And so we worked with the local company to build an AR experience to bring those art features to life, that street art to life. We've also been doing some trials with the hospice in the Hawke's Bay, and that was looking at virtual reality. So how can you create for, particularly through the lockdown period, the hospices, people in there couldn't have guests, visitors. And so we created some experiences where they could experience international locations, travel content and such. But what does that mean for the travel industry? So there's heaps of applications for augmented and virtual reality. So passengers could take self-guided tours through cities without the use of guidebooks. I think this picture was on Craig's slides earlier. You can use AR headsets, and particularly when you pair that with wearables, they're bringing some amazing results around training, and also for engineers and mechanics with work that they need to do in the field. And then for things like passengers, being able to check your hand luggage before you even leave for the airport. That's in the augmented reality space. Virtual reality's got a whole nother set of opportunities. So you could experience the 360-degree virtual city tour before you arrive. or when you're booking at the travel agents, you can experience the business class seat before you fork out the dollars for it. The technology is being proven as highly effective as a training tool, so is being used in some locations for training cabin crew. And also there are several airlines that are testing virtual reality as a form of in-flight entertainment, and particularly good for nervous flyers as well. Moving on, one of the other technologies that is really cool to see starting to come to life is this concept of digital twins. So for anyone who hasn't heard of a digital twin, it's a digital version that virtually represents locations, equipment, materials, and effectively creates a 3D model that you can then run simulations on. So what we've done at Spark, this video up in the top left, is a digital twin that one of our graduates built for us of our digital innovation studio downstairs here at Spark. So we went into lockdown, we'd opened this amazing space that highlighted and showcased different types of innovation. We couldn't take anyone through it. So one of the team built a digital twin that was based off what was down there and using the sensors and things we already had in place, and created a virtual experience that we can use to at least continue to take some customers through when the office is closed. How we're seeing this being applied, we've partnered with a construction company down in the Smart Precinct, down in the Wynyard Quarter, and applying digital twins to construction sites can have huge benefits from an efficiency perspective, but also health and safety. And then you can apply it to everything from specific engines through up to campuses and all sorts. Just keeping an eye on the time. How else that turns up, and one of the active implementations we've got going on at the moment is a small trial around smart cities, and this has been doing great as we've won some awards overseas for this. It was done in partnership with Auckland Transport, and it's set up down in the Wynyard Quarter, the Smart Precinct, and we've got a number of different IoT devices that have been set up to showcase the different ways that you can use IoT in a city context. And then it all is beaming back. So we've got a demonstration downstairs in the Spark building that shows you the dashboards of everything that's being lit up. So what sort of things are in a smart city? You can have smart bins that know when they need to be emptied. So you're preventing overflow of rubbish, but you're also reducing the number of rubbish trucks you have on the road because they're only going out when they need to. We've got smart benches, which you can see on the bottom left there. So they're convenient mostly just for charging and hotspots. They've been installed. The smart lights are a really interesting one. So they can save energy by knowing when they need to turn on and off, but also they can help keep traffic moving smoothly. So there are cameras installed on some of the smart lights that are using CCTV footage to create heat maps of significant congestion points or choke points. The intention with this was to use it as part of the America's Cup, because we thought we're going to have all of these people down at the Wynyard Quarter, but still a great example of how you can bring together different types of technology. Smart parking is another really big one. So understanding when we've got free car parks, and then we're moving into smart intersections where you've got cameras that can count traffic, etc. What that looks like in an airport, and I won't spend too much time because I think Helen covered off a lot of the future airport stuff really well. Some of the emerging things that we are seeing a big trend around is this idea of mobile edge compute. And mobile edge compute means that you take the processing that might need to be done, for example, using AI and video analytics, and you shift it closer to the user, which lets you significantly reduce the latency and means that you can get some really interesting use cases around video analytics specifically. So for example, in this one, you can test to see whether you've got groups of people in one location. We're also testing out using the technology for exclusion zones from a health and safety perspective. So how do you make sure if somebody's detected as starting to move into the exclusion zone, set off a warning? Really requires that short turnaround time or latency that we talked about. So if we go from smart cities, the future will be smart airports and working towards a seamless travel experience. So how can you take the benefits of 5G, but also of the technologies we've got today in the 4G space and with our Internet of Things capability to drive a more seamless experience for customers, whether it's through biometrics, whether it's through passenger and luggage tracking, that sort of thing, or whether it's actually facilitating the back of house of the airport through things like improving turnaround time by understanding your digital twin of your aircrafts, being able to better manage maintenance, etc. So I'll stop there because I think I'm just out of time.
Awesome, wonderful. Thank you so much for your time today, Renee. It's been awesome hearing from you.
Thanks for having me.
Our final speaker today is Jacob Snelgrove, who is the Sustainability Manager at Air New Zealand. Jacob is leading the charge on future aviation trends for zero-emission aircraft, and today we'll discuss some of the emerging aircraft types and Air New Zealand's ambitions to achieve net zero carbon emissions by 2050. Over to you, Jacob.
Cool, thanks everyone. Thumbs up if you can see the screen and hear me talking. Cool, so I'm the Sustainability Manager at Air New Zealand, and I'm working inside the sustainability team, and I'm a part of a cross-functional group of people working on zero emissions aircraft technology for the airline and how we see that playing out over the next 5, 10, 15 years. And the presentation I'll go through really just looks at how we see that technology application playing out here in domestic New Zealand. Starting on this side, framing the problem, aviation today is a small share of global emissions. It's about 2.1% pre-COVID of the globe's carbon emissions. If we take in radiator forcing impacts, that could be slightly higher, but for us, it's actually quite a small share. But the concern for us is that over time, that share is going to get bigger and bigger. We've already seen over the last couple of years, the growth of electric vehicles, the adoption of renewable energy, and the lowering of carbon emissions right across the economy. And as we'll sort of see, aviation, unfortunately, is quite challenged in its ability to adopt low carbon technology. And so over time, that share of global emissions is going to rise from 2.1% to a significantly higher value when we get out towards 2050, when we're sort of aiming to limit global warming to 1.5 degrees in line with the Paris Agreement. More specifically, here at Air New Zealand, our emissions are split with the greatest proportion of them in our international fleet. So 83% of our carbon emissions in 2019, pre-COVID, was from international flying. That is across the Tasman to the Pacific Islands in the US and Asia. Only 17% came from our domestic network, but it's that small 17%, which I think represents some really interesting opportunities given the technology that appears to be coming down the pipeline. And it's that 17% that we'll sort of look at how we can solve for over the next couple of minutes that I'll present. And I just want to add too is that as an airline and an industry, we definitely haven't been sitting on our hands. Aviation has only been around for a short time in its current form. It sort of kicked off in the 1960s with the use of jet aircraft technology. And since then, the efficiency gains that the industry made have been unbeaten across all the different transport forms that you can use today as a consumer. And here at Air New Zealand specifically, we've managed to achieve a 23% improvement since 2009. And while that's great, it's nowhere near enough in order to meet the challenge presented by our 1.5 degree limit by 2050 and achieving net zero carbon emissions by then. So when we look at the, just change slides, the challenge, aviation needs to get from 1,000 megatons of CO2 as an industry in 2019 all the way down to zero in 2050. And innovation already is focusing around 3 major alternative energy sources. The first of these is hydrogen. And there's a lot of noise about hydrogen that we've made as well as the industry. And we'll dig into how the aircraft could play out in a little while, but just touching on how the fuel's made itself to start with. You take a bit of water, you take some renewable energy, you combine it in what we call electrolysis, and you create hydrogen gas. And that's a really great form of energy for aviation because it's super light, and it means that we can put it on airplanes and fly them a relatively good range. But the challenge with hydrogen is while it's really light, it's really hard to store in a volume perspective. And to play a comparison out, if I had a liter of jet fuel today, which is what we have in the wings of our planes, if I wanted the same energy in hydrogen, I'd need over 3,000 liters of hydrogen to capture that same amount of energy. So to bring that volume down, you either have to store hydrogen under extreme pressure or keep it really, really cold, sub 250 degrees Celsius. So that presents significant storage challenges for airplane design. And then the cost of hydrogen is also quite restrictive, as it requires quite a lot of renewable energy to produce. And finally, as of today, there's no infrastructure to support hydrogen aircraft here in New Zealand or globally. We'd have to stand up this new supply chain for an energy source, which is still in its infancy. But it does present a great option for aviation because it is so light. And as you'll see soon, that's something that we're certainly pursuing in our sort of low carbon domestic solution. The next one's battery technology. So battery tech really works like your Tesla car today. It's a battery plugged into an electric motor. It's the most efficient form of electric transport because batteries are really efficient. There's no wasted energy as there is with hydrogen. But the batteries are super constrained around weight. And again, to play out another analogy, if I was to fly my Airbus from Auckland to Wellington today, that consumes about 2.5 tons of jet fuel, which sounds like a lot, but is actually quite efficient. If I wanted to fly my battery plane, instead of burning 2.5 tons of jet fuel, I'd need over 200 tons of batteries. And for perspective, the plane flying that route, the Airbus, only weighs 70 tons in total today. So it's totally unfeasible in terms of fitting that much weight in terms of batteries to fly those sort of ranges. So given that, we see battery applications being restricted to those smaller payload sizes, so sub 20 seats and shorter range routes where the weight isn't so much of an issue. And again, just like hydrogen, we have challenges around the infrastructure. Currently, no airports have, there's one airport down in Christchurch that has a small electric plane charger, but nothing at the scale needed. And so that's, again, more investment in new infrastructure as it sort of comes out. And the final one, which isn't the focus of today, but is the last sort of fuel, alternative energy source that's being pursued, is use of sustainable aviation fuels. And so that looks like, feels like, and smells like jet fuel, but it's made from a sustainable source, whether that's used cooking oils or forestry waste or municipal waste. But again, that has challenges because that still emits carbon. It's not a zero emissions technology like hydrogen or battery, where the only byproduct is water. Sustainable aviation fuel still emits carbon, and it's how you sequester that carbon out of the air that creates this sort of circular system. So it's not a perfect solution, but it is perfectly suited to the planes we have today that fly long haul and generate that 80% of emissions, which are really hard to abate with the other two zero emissions options. So with that in mind, we'll look at the opportunity. So for New Zealand, we're ideally suited as a small country to adopt this zero emissions aircraft technology, whether that's battery or hydrogen. Number one, our domestic network is incredibly dense compared to a lot of other countries, so more akin to the Nordics in terms of how we fly. Over 60% of our domestic routes that are flown by turboprops are under 350 kilometers, which is a really short distance when we compare ourselves to other countries in Europe or the US. Additionally, we have a really high makeup of renewable energy. So these planes need renewable energy either to charge or to make hydrogen. And a big problem all around the globe is how you scale that renewable energy to meet the need. And we've already got a grid here, which is 80% renewable energy. So when you take short range flights, which are ideally suited to these planes, and the renewable energy problem, you start to create an ecosystem which could be really well suited. And then you layer on the final piece of the puzzle, which is the fact, as a country, we're met with islands, huge peninsulas, and of course, significant mountain ranges, which make the underlying substitutes limited. Outside of Hamilton and Auckland, we can't get on a 4-lane motorway and commute between major centres. The cost and time around developing high-speed rail is significant, and also, roading and bus options sort of rely on that road, which doesn't really exist. And the cost and additional carbon from that is also something that needs to be taken into account when we consider the future that aviation could bring. And so finally, just looking at the solutions that we're seeing emerge, a new wave of aviation innovation could transform the way that we move by air here in New Zealand. And so I've touched on hydrogen-powered flight and the use of hydrogen through the green form of producing hydrogen. And those aircraft there on the left, here in New Zealand, we've partnered with Airbus in an MOU late last year, which was to investigate how we could see these aircraft deployed across the country. And while hydrogen is costly and hard to store, the technology projections we're getting from Airbus indicate that we could see these hydrogen-powered aircraft by 2035 flying a large number of our domestic routes, potentially reaching the whole length of the country. And what's exciting here for New Zealand is that we currently import all of the jet fuel that we consume. We don't make any of it here in New Zealand. And with hydrogen, the cost of trying to import is really, really prohibitive. So it presents this opportunity to develop a new industry here in New Zealand, a new supply chain, a new form of growth and regional growth for New Zealand and its economy, as well as providing zero emissions flight right across New Zealand. But because of the cost of hydrogen, we sort of see these hydrogen-powered aircraft operating very much like we see planes today. They operate on a schedule. We have to maximize utilization and sort of get as many people in them as possible to keep the economics sort of working. When we look at these battery planes, which is the one there in the middle, these aircraft offer much lower direct operating costs because the cost of energy is really low. And while they're challenged on weight and payload, what that means is we could see these smaller electric planes connecting regional centres which can't be connected today because we can't make the economics work. Or they're giving greater frequency and greater customer service to routes where you could potentially only have one flight operate today. And finally, when we look at this sort of eVTOL here on the right, there's sort of a culmination of this battery electric technology and thinking differently about how we offer aviation to the customer. So these aircraft take off and land vertically and they're powered by batteries. And so what that allows us to do is to rethink how we offer customers transport. So we could move away from airport hubs. We can connect customers closer to where they originate from, so closer to home, and take you closer to where you want to go. And so for that sort of regional connectivity point of view, if we looked at Auckland, for example, I could jump on one of these electric aircraft downtown in Auckland, take off vertically, fly to somewhere that is otherwise prohibitive by road, say the Coromandel Peninsula, or up north to the islands. Down the south, you can traverse the high mountain ranges in what is only a 10 to 15 minute flight, where it would have been a 2 to 3 hour car journey. And because of the cost reduction that batteries offer, you could potentially do that at equivalent cost to, say, a taxi or an Uber today. And so it's this proposition that sort of culminates the technology and truly offers a disruptive shift around how we operate planes conventionally today. And so, yeah, I guess here at Air New Zealand, we are doing a lot in this space to make this all come true. At the end of last year, we released a product requirements document to market, which was sort of outlining our principles around how we want to adopt these aircraft. And we've had really encouraging responses from the market. Submissions only closed a couple of weeks ago, and we've had a significant number of responses come in. And over the next few months, we'll work through those responses and hopefully towards the end of this year, the second half of this year, have some information to share around who we're seeing as the leading contenders and sort of the most promising concepts that are coming to market. And I'll close there for questions.
Awesome. Thank you so much for going through that, Jacob. It's really interesting to see kind of the three-pronged approach that we're taking to kind of moving towards sustainable aviation. And I guess one of the first questions I've got is, do you think kind of the commercialization of solid state batteries will really be a phase change in the viability of electric aircraft?
Yeah, that battery innovation curve is a really interesting one to follow. And we sort of, if you look at the watt hours you can get into a battery for every kilo that it weighs, as that steps up that curve and you're getting more watt hours, more capability in the battery for each payload, that range really starts to grow, and it becomes exponential how far those aircraft can fly, the destinations they can reach, but also their resilience in the operation. So being able to stand up to bad weather and truly offer, the sort of service our customers expect. But it is really hard in terms of trying to make sense of how those play out. And then you also have to layer over the infrastructure costs that battery planes bring with charging infrastructure, where hydrogen may be cheaper from an infrastructure point of view. But I think if the battery innovation curve follows the projections that we're seeing, I think it does offer some really interesting innovations for us in the future.
With sort of the renaissance of kind of supersonic travel kind of coming back to life in the States with startups like Boom and such, do you see them being possible to be folded into kind of a sustainable aviation future, or they're more a pipe dream for kind of more affluent, kind of well-off people to use to get places quick?
Yeah, supersonic flight is really challenged around energy. It demands a huge amount of energy. And the Boom concept, for example, is only going to be able to use jet fuel, and they're proposing to use sustainable aviation fuel. But as I said, sustainable aviation fuel is limited for supply, and it is really costly. And so if you have a limited supply, so currently we couldn't even, if we took all of the world's supply of SAF, we couldn't even fuel Air New Zealand's fleet, let alone the global fleet. So if I propose to make a supersonic aircraft, which is really heavy and really needy in terms of energy, all I'm doing is taking that limited supply of sustainable aviation fuel and giving it to a very select group of individuals who can afford to travel at super fast speed. So I think for those aircraft concepts, they, as an aviation geek, I think they're amazing. But I think in terms of trying to achieve that global decarbonisation ambition, they're probably not where the industry needs to head.
Awesome. And we've just got one final question here. So that will be, what are the future of turboprops, and do you see them being phased out in the future?
No, definitely not turboprops. Turboprops, I think, are, if anything, going to become more and more prevalent. That the concepts we've seen from Airbus, for example, out to 2035, all embrace a propeller. And so they're talking around concepts of 100 seats or more. So it could be in a future domestic network, we could see a higher proportion of turboprops flying that are hydrogen powered. And then while the jet aircraft technology catches up, those bigger jet airplanes are restricted to a couple of key routes where you need that higher capacity and higher speed. But the actual turboprop aircraft around the network are serving more destinations that otherwise a jet airplane might today. So I actually think it's the opposite. I think there's probably growth in the turboprop fleet.
Awesome. Cool. Thank you so much for that. And